in your email, and I know it's long, but they're my notes. Okay, so instead of you having to write down my notes for this stuff because it's just a lot of steps and a lot of pictures, I just sent you or shared with you my notes that I created with OneNote. Within there's some links though that are going to be useful to us, but hopefully that's something that you guys use. I don't want you to sit in class and us just kind of just write a bunch of notes down and not get to the kind of the meat and bones of construction. Okay, so those are there if you get stuck or confused with something and you need a step-by-step kind of breakdown to do these. Okay, now there's only a handful of them here. Okay, these are the ones that we're going to talk about today. For the most part, we don't get to this last one. And the first couple are the ones we did yesterday. In addition, okay, if you click on, you see what the second link here in blue that says Math Open Reference. If you click on that, it's going to take you to this site here. Okay, and this site has a kind of a visual demonstration for pretty much every one of the constructions that we're going to do and beyond. Okay, so kind of talking about what we did yesterday. One of the key ones we did yesterday was find the perpendicular bisector of a line segment. So I'm just going to click on that. I want to kind of show you what this thing does. So there's a couple things here. One, if you just scroll through here, it'll show you the step-by-step kind of procedures that are going on. And I believe, if you think about it and you read these, it's basically talking about the proof of these constructions and why they work the way they do. But the thing that students usually appreciate is that if you click Run, it'll actually show you the steps that we went through yesterday. Remember, we made a segment or a compass bigger than half that segment, drew arcs above and below, kept the segment or the compass the same length, did the same thing from the other side. It creates those 2 points up top and bottom, straight edge connect, and you have your perpendicular bisector. Okay, so it will show you all of those steps that you need to go through, to do that. Okay. Now, there's a lot of other constructions that are on here, okay, that are going to be of use to us. So I want to scroll down through one. See if I can find triangles, mid-segment, altitudes. There we go. So I want to put on this one that says circumcenter of a triangle. I just want to show you how kind of detailed and elaborate some of these things can become. And we will do this in a couple weeks. We're going to try to find something called the circumcenter. So find the circumcenter. The first thing we have to do is find the perpendicular bisector of a side. So that's the perpendicular bisector. That's what we did yesterday of segment AB. We're going to do the same thing for another side, segment BC. So that's the perpendicular bisector of BC. We'll draw that line, and then we're going to draw that line so it intersects the other one. And it gives me point O there. Okay? Point O is what we call the circumcenter. Okay? If you remember what we talked about the other day when we did section 3738, we said we're going to find the equation of those lines. Those black lines we'll find the equation for, because this point here, that point is the same distance from A as it is from B as it is from C. So if I were to take that distance right there and put it on my compass and draw a circle with center at O, that circle is going to go through A, and go through B, and then go through C. Find what we call that circle. We call it the circumscribed circle. Every triangle has one. Every triangle has a circle that can be drawn through all 3 points. But you have to find that center first before you can do that. All right. Let's see if I don't know if there's actually one that actually goes one step further and shows you that circle. Circumcircle. There we go. So every step of this would be exactly the same thing they did there until after they find O. So find the perpendicular bisector of AB here, which is what we did yesterday. Find perpendicular bisector of BC here in a moment, which is what we did yesterday. That gives us a point O here. Now they're going to go point O. They're going to make their compass go through C, draw a circle, and it goes through A and B as well. That's called the circumscribed circle, or sometimes called the circle. But like I said, every triangle has one of those. Okay? There's going to be two things that we do. We're going to do that with a protractor and compass and straight edge and all that kind of stuff later on. But we'll also work on that algebraically, and we'll be able to find what is the equation of those black lines, then what is the point O, and then we'll have enough tools to find the equation of that circle. Okay, so those are some of the things that we're going to do when we put this thing in the coordinate plane. All right. So what I want you to understand is that there's different ways that we're going to approach this problem coming up with that circle. Okay, one graphically and then the other one algebraically. But this has got a slew of things that we can construct. Okay, we'll deal with, I don't know how many are on here. It looks like there's probably close to, 50 or 60 of them on here. We'll probably do maybe 15 to 20 of them. Okay, we won't do all of them. But that would be kind of a reference for you if you're getting stuck, you miss a day, something like that, and you want to see what the constructions are that we talked about. That's the first place to go. Okay, there won't be anything that we do that is not on that list. Okay, let's do something similar to what we did yesterday. Let's take a line and make it a good size line. Put it about halfway through your screen. There's one feature on here that I don't like. I wish that I could just click a point and add a point to my page anywhere I want to. So they don't have that feature, but we can kind of cheat it a little bit. Take your compass and just put it. So don't put it in the middle where I think the midpoint is. Okay, I think the midpoint is kind of like right here, right? Somewhere in that vicinity. Kind of come over here a little bit more, and then just don't click and move. Just tap the knob, and it will put a point there. Does that make sense? Okay. If you click and move, it'll start drawing the arc. We don't want the arc. We just want that point. I'm going to move my compass away. You guys don't have to, but I move my compass away. How many lines go through that point that are perpendicular to the given line? Just one, right? We're going to find that one. We're going to draw that one in here, construct that one. Okay? Now, the first thing we're going to do is we're going to take our compass and we're going to put it on that point. And we're going to adjust our compass so that it's to a size in which I know it's going to, and when I draw an arc, it will intersect that line to the left of the point and to the right of the point. Okay? So mine here is good. I'll be able to intersect. I'm just going to draw the circle real quick to make it just a little bit quicker. But that intersects on both sides of that point, right? You want to make sure that you do not do something like this. You see how that only intersects that line one time? Okay. So that's the requirement here. We have to be able to take our compass and at least intersect to the left of this point and then to the right of that point. Now, if you want to draw the whole circle, that's fine. Most of the time on that Math Open reference I showed you, they're not going to show the whole circle. Okay, they're just going to show the arcs. So what just happened? Okay, you don't need to do this. I'm going to put points here. I'll put a point right here. I'll put a point right here. You don't have to do that. what did we just do? What that first step is all about is taking, no, if it's full. That's not terrible. If that's my initial line, I wish that was the same yellow as the background. But it takes the initial line and makes everything on the outside of those arcs kind of disappear. Does that make sense? So now we have a segment, just like we had yesterday. Does that make sense? Okay, and we're going to find the perpendicular bisector now of the segment that is between those two arcs. Don't you remember the steps we did yesterday? It said you're going to take the compass and you're going to put it on that end point of your segment. You're going to make your compass bigger than half the segment, right? Okay, so right now, you don't have to draw this part either. I'm trying to get us to focus only on dealing with that red segment. That's all I'm interested in, trying to find the perpendicular bisector of that red segment. So I use the endpoints of that red segment, make my compass bigger than half. Okay, you can make it as big as you want, but it just has to at least be bigger than half. I'm going to draw an arc above and an arc below. I'm going to take the same distance on my compass, come over to the other endpoint, draw an arc below, and draw an arc, draw an arc above. Okay? Those two intersecting sets of arcs should be now collinear with the initial point that is on your line. Okay? If I take my straight edge ruler or whatever and line those up from there to there, does that pass through that given point that we had on our line? And when we put our protractor on it, is that a right angle? Yeah. Okay? So that's the idea of being able to take any line that we want, and put a perpendicular line through any point on that line. Okay? Okay? Again, that demonstration is on that math open reference as well. I want to do another one that is very similar to that. Okay, so let's clear things off here. Let's draw another given line. So maybe and put it in about the same vicinity as the last one, about halfway down the screen. Next thing I'm going to do is I'm going to take my compass and I'm going to come over like right there. Okay, don't go too high. Don't go too low. Somebody in the last class said, well, why are you always doing these horizontal lines? It don't matter what your line is. You want to make a line like that? If I want to make a line like that, you can do exactly what we're doing, and you're going to find a line that's perpendicular to that. That's fine. I just think initially, to determine whether our construction looks legit, looks like we made perpendicular lines, to make the first one kind of as much horizontal as we can. So I'm going to move my cursor, my compass, just above that line and put a point. Okay? I just don't want that point to be, really far up on my screen because we're going to run out of room. Okay? And when I do that, it makes 2 points, right? Okay? But I'm only really looking at that really thick one. Okay. How many lines go through that point? None yet, but how many could go through it? Could it? Does that line go through it? Okay. That line goes through it. That line goes through it, right? When I have only 1 point, there's an infinite number of lines that go through it. How many of those infinite lines, though, are perpendicular to the line that we have? There's the one. Okay? Let's find that one. Okay? So the first thing we have to do is exactly the same as what we did in the last construction. We need to be able to not look at the entire line here, but just look at a chunk of that line. And the chunk of that line is found by putting your compass on that point. And now you're going to draw an arc so that it intersects this line 2 times. I draw a whole circle, but intersects that line 2 times. If it doesn't intersect your line 2 times, you need to adjust your compass. Now, my hopes are that you don't draw like that intersects 2 times, right? Do you see how close those 2 points are? Okay, it'll work because we're using this program. If I had that in front of me with a legitimate compass in my hand, that's going to be a problem. Okay, that's going to create some imprecision. So we want to make that kind of as big, I'll say as big as possible, but the bigger the better. And usually, like on a homework or the end-of-course exam, like I said, they're not going to show the entire circle. They're not going to show the entire arc. They're just going to show those 2. Okay? But now what that allows us to do, just like the last one, what that's going to do is say, we're not going to look any longer at that part of the segment or that part of the segment. We're just going to look at the black stuff here, right? And now we're finding the perpendicular bisector of the black one. Okay? So that's kind of the idea of that first step. We're going to find the perpendicular bisector of that blue segment. Okay, so if that's the case, then we're going to put our compass right there on that first intersection point. And now we have to make our compass. We have to change. And my suggestion is this sometimes will work. If you don't change your compass from that first red circle that I made, sometimes it'll work for you, sometimes it won't. You just have to make sure that your compass right now is bigger than half of this segment here that I've made blue. Okay? Sometimes that will be the red circle that you made. That might be bigger than half the segment. It's just a personal, depending on the sizes that you chose, whether it's going to be true or not. I always like to maybe adjust mine a little bit to make sure it's bigger than half. Okay? Make an arc that goes above and below. And then I'm going to come over here to this intersection point and make the same thing. Okay? Again, most times you're going to just see that portion of the arc, that portion of the arc, and the same thing over here. You're going to see that portion and that portion. Okay? If you kept your compass the same length as this red arc, this top intersection will actually go through that point right there. Does that make sense? Okay, so some of you might have seen that. If you made your compass smaller than this original circle, which sometimes will work, your intersection points would actually be below that red point. Okay? However, if you have 3 points or 2 points, depending on where your intersection of arcs up here is that enough to make a line? Can I connect 2 points, make a line? So that point there, connected down to that point there, does that pass through that given point that we started with? And if we grab our protractor, is that a right angle? Okay. So that is creating that's going back to that postulate we said. If we have 1 point that is not on a given line, and there is one and only one perpendicular line that goes through it, and that's the one. Okay. Just kind of demonstrate this rule. You don't have to do this, but the idea is everything we've been doing has been a horizontal line, right? Doesn't have to be horizontal. I can look at that line right there. Let's say that, I want to see how many points or how many lines go through this point perpendicular to that line. Should be one, right? So what I'm going to do is I'm going to grab my compass, put it on there, and draw those arcs. Okay, so what's the problem there? Doesn't go through twice. Okay, so here's the idea. If it doesn't go through twice, if you're doing this on your paper in front of you, you have an option. Usually people don't want to erase that arc, so the option is to take my straight edge and actually extend that line a little bit further. Does that make sense? But since we're on here, it makes more sense to just hit the back button and then adjust my compass. And those are the things that are going to be asked on the end of course exam. They'll do something. They'll say, this is what we're trying to do. And they'll go through 2, 3, 4 steps and say, okay, what was wrong? What was the issue? Okay, how can we fix that issue? We'll draw that arc. Come down here. Do the same thing. And now I'm concentrating on the segment between those arcs. I'm going to go there. Extend a little bit, lock it, draw arc here, come up here, draw my arc, and then do the same thing over here. Now if we take our segment tool, there, to there, so that pass through that given point. And then if we put our protractor on there, we have to move our protractor around a little bit. To get that, the lines there, is at a right angle there. To get that up correctly. Should go through 90, should be a right angle. Okay? All right. What happens, so those construction guys, the construction of an angle, construction of a segment, and then construction of perpendicular segments are the basis for constructing anything else throughout the entire course. Okay? It's just how do we, maybe construct two angles together that are both right angles to create maybe a rectangle. Okay? How do we create maybe parallel lines by constructing congruent angles? So that's going to be something that we do over and over and over again. New constructions, we'll do these three kind of foundational types of constructions multiple times and in different combinations to get other features, okay, other types of shapes to work out. Do you have questions on this? It's okay? Is this something we can do? No new homework this evening, okay? My suggestion, though, is make sure that you do kind of these last 2 days. We haven't had homework, but that should free up some time to maybe go back through, maybe do a couple of these constructions on your free time, maybe look at those videos that were on this original web page here, okay, just so that you are sure you understand those. Okay? Every year there's 1 or 2 questions on the end of course exam that are about construction. So make sure that we understand them. That's all I've got for you.